Welcome to this third module of simultaneous equation. In previous modules, we have seen about simultaneous equation, we have seen about characteristics of simultaneous equations, their applications, and we have covered some methods of solving simultaneous equations like graphical method, comparison method, and substitution method. Today, we will do another method which is known as elimination method. In elimination method, we have three cases. So let us look these cases one by one. Case number 1. If the coefficient of one of the unknown variable in both the equation is equal and of the opposite sign. Now in this condition, we will see one example. Suppose we have equations 3x minus 5y is equal to 11, 4x plus 5y is equal to 3. Here if you look, the coefficients of y is 5 and which is common in both the equations, but the sign of this coefficient is different. In this way, we identify first case, that is, if the coefficient of one of the unknown variable in both the equation is equal and of opposite sign. Now if we identify an equation to be of first type, how do we solve it? Now from the given two equation, we simply add the two equations. After doing so, the variables having the opposite sign got cancelled. So we are left with only one unknown variable. After solving, we can find the value of this unknown variable, and after solving, we can put this value in any of the given equation to find the value of other unknown variable. Okay. Now let us see. We have an example 3x minus 5y is equal to 11, 4x plus 5y is equal to 3. Let us mark them equation number 1 and equation number 2. Since we have the coefficient of y as same but with opposite sign, we simply add the two equations, equation number 1 and equation number 2. So we have the value of x as 2. Now putting this value of x in equation number 1, we have the value of y as minus 1. Hence the two roots of this equation are x is equal to 2 and y is equal to minus 1. Now case number 2 for elimination method. In second case, what we do, in the given equation, the coefficient of one unknown variable in both the equation is equal and with the same sign. If you look at the example, we have x plus y is equal to 10, x minus 2y is equal to 6. Here the coefficient of x is same and also the sign is same. In this case, what we do, we subtract one equation from the other. This eliminates one unknown variable and gives the equation in other unknown variable. Solving this equation, we can get value of one unknown variable and we can put this value to solve and find the value of another unknown variable. Let us see how it is done. So we have an example x plus y is equal to 10, x minus 2y is equal to 6. Let us mark them equation number 1 and equation number 2. Now since the coefficients are same, we subtract equation number 2 from equation number 1. While doing so, we have to change the sign of each element of the second equation. That is, we change the sign of x as negative, we change the sign of minus 2 as positive, and we change the sign of 4 as negative, and we simply add them. This eliminates variable x, so we have the value of y as 2. Now we can put this value of y in any of the given equation. In this case, I am putting the value of y in equation number 1. So we have the value of x as 8. Hence the roots of this equation are x is equal to 8 and y is equal to 2. Now we come to case number 3, in which if the coefficient of unknown variables in both the equations are different. This is an important case as most of the problems in simultaneous equations occur in this form only. In this, for solution, what we do, both the equations are multiplied by constants so that the coefficient of one unknown variable becomes same. Now the given equations reduce to either in case number 1 or case number 2. Solving the equations gives the value of the unknown variables. Now let us see this with an example. We have the equations 3x plus 8y is equal to 17, x plus 10y is equal to 13. Here none of the coefficients are same. Let us see this with an example. We have the equations as 3x plus 8y is equal to 17, x plus 10y is equal to 13. Now here none of the coefficients are same. That means this is of case number 3. So let us mark them equation number 1 and equation number 2. Now we need to eliminate any one variable. Suppose I need to eliminate the variable y. For this I have to make the coefficients of y same. How do I do that? I have to multiply equation number 1 by 5 and equation number 2 by 4. So we have 15x plus 40y is equal to 85 and 4x plus 40y is equal to 52. Let us mark them equation number 3 and equation number 4. Now if we compare this with case number 2, it is of the form in which the coefficients are same with the same sign. So we have to subtract one equation from the other. Now subtracting equation number 4 from equation number 3, we have the value of x as 3. Now if I put this value in equation number 1, I can get the value of y as y is equal to 1. Now the most important method, we have cross multiplication method. This is also known as Cramer's rule. It can be applied to the equations if the equations are of the form a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. If equations are not in this form, first we have to convert or transform the equations into this standard form. Now how do we do this? We take x upon, y upon and 1 upon. And besides this, we have to place the coefficient of the next element. For example, if we are calculating the value of x, we need the coefficients of y and c. So we have b1, b2, c1, c2. And for y, we need the coefficients of c and coefficients of x, that is c1, c2, a1, a2. And for 1, we have coefficients of x as well as coefficient of y, that is a1, a2 and b1, b2. As the name suggests, this is cross multiplication. So we have to multiply them in cross order. So b1 is multiplied with c2 and b2 is multiplied to c1. In the same manner, c1 is multiplied to a2 and c2 is multiplied to a1. Similarly, a1 is multiplied to b2 and a2 is multiplied to b1. So we have x is equal to b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1, and y is equal to c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. Here I would like to mention the value of a1, a2, b1, b2 and c1, c2 are all coefficients, and we have to take their sign in consideration. That means if the value is negative, we have to take it negative also. Now there is no need for you to remember this formula. Just remember the flow or how we obtain this step. Let us see it with an example. Suppose we are having equations as 3x plus y is equal to 11 and 4x minus 2y is equal to 8. Let us mark them equation number 1 and equation number 2. In order to solve this using simultaneous equation, we have to first rearrange them in the standard form, as these equations are not in the standard form. So after arranging, we have the values in the standard form as 3x plus y minus 11 is equal to 0, 4x minus 2y minus 8 is equal to 0. Here you can note down in rough the coefficients of x and y. So we have a1 a2, b1 b2, c1 c2. The value of a1 is 3, a2 is 4, b1 is 1, b2 is minus 2, c1 is minus 11 and c2 is minus 8. Now we write it in x, y and 1 form, that is x upon the coefficients of y and c, that is 1 minus 2 minus 11 minus 8. For y, we need the coefficients of c and x, that is minus 11 minus 8, 3, 4. And for 1, we need the coefficients of x and coefficients of y, that is 3, 4, 1, minus 2. Put a cross, and how do we multiply? We make multiplication as 1 into minus 8 minus of minus 2 into minus 11. In the same manner, we have minus 11 into 4 minus minus of 8 into 3. Similarly, we have 3 into minus 2 and minus of 4 into 1. On solving, we are getting the value of x as 3 and the value of y as 2. Hence, we have the roots x equal to 3 and y is equal to 2. Let us take another example. We have the equation 2x plus 3y is equal to 17, 3x minus y is equal to 9. If we compare this, it is not in the proper order. So we have to first arrange these equations into standard form. So we have 2x plus 3y minus 17 is equal to 0, 3x minus y minus 9 is equal to 0. Mark them equation number 1 and equation number 2. Here the coefficients are a1, a2, b1, b2, c1, c2, that is 2, 3, 3 minus 1, minus 17 and minus 9. Simply we solve it. So we have x upon minus 3 minus 1, minus 17 minus 9 put across. Then we have y upon minus 17 minus 9, 2, 3 put across, and 1 upon 2, 3, 3 minus 1. On solving, we have the value of x as 4 and the value of y is 3. Now at the end, we will look back what we have covered in this module. We have seen elimination method and we have seen the three cases of elimination method. The first case was if the coefficient of one of the unknown variable in both the equation is equal and of opposite sign. So we simply add the two equations. The second case was if the coefficient of one of the unknown variables in both the equation is same and with the same sign. So we have to subtract one equation from the other. The third case, if the coefficient of unknown variables in both the equations are different, we have to make coefficients of any one variable same by either multiplying it with a constant value and cross multiplication method. So in this module we have covered two methods. In the next module we will see how equations are reduced into simultaneous form for solution. Thank you.